Hello friends, I am Praveen Chobe. I welcome you all to this session. In today's session, I am going to talk about solution of first order ordinary differential equations by second order Runge Kutta method. This Runge Kutta method is popularly also known as RK method. So we need to understand here we are trying to solve first order ODE by second order RK method. So in order to solve that, there are total 7 formulas those we are going to use. First formula out of which is to calculate the step size. So when we are calculating the step size, that is generally calculated as h is equals to here h is equals to x1 minus x0, where x1 is the new value of x and x0 is initial value of x. Moreover, this can also be written as xn is equals to, or new value of x, xn is equals to x0 plus n into h, which is a generalized formula. This formula is also used in several other methods such as Euler's method. So new value of x, that is xn, is equals to initial value of x, x0 into n into h, where h is step size and n is number of iterations those are required. Second formula is dy by dx is equals to f of xy, which is again this formula is also same, dy by dx is equals to f of xy. As we know, dy by dx is the term which is showing differentiation as we are solving first order ODE, ordinary differential equations. So a differential equation, first order equation, is having this term that is stated dy by dx is equals to f of xy. We need to understand dy by dx is always the function of xy. Then k1 will say it is constant, or Runge Kutta method constant k1 is given by h into f of xy. k1 is equals to h into f of x comma y. Likewise, k2, another constant, is given by h into f of x plus h, means instead of x you need to take it x plus h comma y plus k1, where k1 is the constant we know, this one k1 is the constant we know, so that part is added here in term of y. Then finally k, from these two values of k1 and k2, k is calculated as k is equals to 1 by 2 k1 plus k2. This is the value for k. And why to calculate this k value is to calculate new value of y. So new value of y, that is yr, is given by yr minus 1 plus k. K value just now I have stated how to calculate that. And finally, the seventh formula, which is again very normal and very popular formula, that is number of iterations. How many iterations you require to perform for solving the equation, that is given by n. Number of iterations is equals to n, which is equals to xr minus x0 upon h. xr is new value of r, or moreover final value of r. x0 is initial or starting value of x. This is xr is final value of x, x0 is initial value of x. Final value of x is xr, initial value of x is x0. h is step size, h standing here is for step size. So this is normal formula which you may find in the previous video, that is on Euler's modified method. In that video also you can find this. Then if you have got these 7 formulas to be used, 1 to 7, if you look at all these formulas, how to use them, that I am going to tell you. So we need to understand, friends, what we are doing here is we are solving the first order ODE, ordinary differential equations, by second order RK method. Okay, this was first order ODE, we are solving by second order RK method. Okay, then we'll take one example to implement or to use the method which I have just now suggested or just now explained. First example is, in the first example itself, dy by dx is equals to x plus y. This is the value given. Dy by dx is equals to x plus y, and y of 0 is equals to 1. This is initial value given. One more thing which is given in the problem is h. H is equals to 0.1. We are supposed to find out y of 0.2. Y of 0.2 has to be found out by using second order RK method. So for second order RK method, these are the formulas. You can remember it like second order RK method is using K1 and K2. K1, K2, these two constants are used. This is second order method, second order RK method. Okay, 2 times K is used. Likewise, you can remember it. So let us see what data is given and what we need to understand out of the data given in the problem statement. First thing I have understood that is f of x comma y means function of xy, which is nothing but dy by dx is equals to x plus y is given in the problem. Then see, this was the first thing given. Then I have the equation y of 0 is equals to 1. This equation to be always compared with y of x0 is equals to y0. So I will understand x0 is equals to 0 and y0 is equals to 1. This I need to understand out of it. Hence I have written here x0 is equals to 0 and y0 is equals to 1. I have understood it from this equation. Y of 0 is equals to 1. Hence I have considered this as x0, this as y0. Then step size h, which is given in the problem, is equals to 0.1. Moreover, one more equation is given, that is y of 0.2 we are supposed to found out. So it means y of x, the meaning is simple. When x value is 0.2, we are supposed to find out the value of y. That's the meaning out of this statement. When x is equals to 0.2, so this value we are considering it as xr. When xr value is 0.2, we are supposed to find out yr by using second order Runge Kutta method, that is RK method. So in this RK method, first step we are doing, or in the solution, first thing we are doing is to calculate number of iterations required. Number of iterations required are n. Those are calculated as xr minus x0 divided by h. xr is final value of x, that is known now, 0.2. At this value we are supposed to calculate y, that is why this is 0.2. x0 is 0. h is the step we are using, that is 0.1. So if I put all these values in the equation, I will get number of iterations is equals to xr minus x0 divided by h equals to 0.2 minus 0 divided by 0.1, that is 2. So 2 number of iterations are required to solve this. That's we have understood. Then let us start with the iterations. First iteration I am going to take. As we know, there are 7 formulas. All 7 formulas I am going to use for first iteration. See how to do that. In the first iteration, step 1 is to find out f of xy for initial values, that is x0 and y0. In the given equation, means the equation which is given in the problem, that is f of x comma y. Actually the equation which was given is dy by dx, and dy by dx we are always considering this as function of xy. So function of xy which is given in the problem, that is dy by dx is equals to x plus y. If I want to calculate value of this f of xy at x0 and y0, then I need to put here x0, y0, values of x0 and y0. When I put those values x0 and y0, I will get f of x0, y0 is equals to x0 plus y0. So friends, we'll start with the steps one by one. In step 1, we are supposed to find out the value of f of xy at x0 and y0. So my equation of f of xy is f of xy is equals to x plus y. If I want x0, y0, I will make it x0, y0 here. x0 is 0, y0 is 1. So if I put these values, I will get f of x0 comma y0 is equals to 1. This is first step. In second step, I am supposed to calculate k1. k1 of 1 I am saying. k1 of 1 will be given by h into f of x0, y0. So f of x0, y0 just now I have calculated. H value is known to me. I will put these values in the given equation. I will find k1. So k1 I have got equals to 0.1 into 1, that is 0.1. The next stage is to calculate k2. So k2 of 1, as we are in iteration 1, k2 value in iteration 1 will be given by k2 of 1 is equals to h into f of x0 plus h comma y0 plus k1. The meaning of which is, instead of x you need to take x0 plus h, and instead of y you need to take y0 plus k1. H value is known, k1 value is known, x0 is known, y0 is known. So you can calculate that as x0 plus h. x0 is 0, h is 0.1, so it becomes 0.1. Then y0 plus k1 is equals to 1 plus 0.1, that is 1.1, right? So we have got k2 is equals to here, after putting all the values in this equation, k2 is equals to 0.12. Step 4 is to calculate k. Once we calculate the values of k1 and k2 in iteration 1, so next step is to calculate k. So k in iteration 1 is given by k raised to 1, that is equals to 1 by 2 k1 in iteration 1 plus k2 in iteration 1. So if I put the values of k1 and k2, 1 by 2 is constant as it is. I will get k1, sorry, I will get k in equation 1 as 0.11. Then once we get the value of k, next work is to calculate y1, that is new value of y. So y1 is equals to y0 plus k1, that is value of k in iteration 1. So y1 is equals to y0 is 1 plus k raised to 1 is 0.11, so it becomes 1.11. So y1 I have got is 1.11. That means at the end of iteration 1, y value is 1.1, meaning of which is again to be understood at x is equals to 0.1, that is x is equals to x1. See, to start with, when x0 was there, x0 was 0, y was equals to 1. Then the new step we have got here is, when x becomes x1, y becomes y1. y1 is equals to 1.11. x1 we are supposed to calculate, so we are calculating x1 as the formula for calculating xn is equals to x0 plus nh. As this is first iteration, n will be 1. x0 is 0 already, it is known, so hence we'll get this equals to 0 plus in bracket 1 into 0.1, so which is equals to 0.1. Other meaning of which is, first value of x was 0 that is x0 was 0. Next value after first iteration is 0.1. So for x is equals to 0.1, we have got y is equals to 1.11. Then next thing is, it is asked in the problem to find out the value of y at x is equals to 0.2, and we have also calculated n number of steps we have got is 2. So we need to take another iteration. So when I am taking another iteration, that is iteration 2, I can say in iteration 2 x2 is equals to x0 plus 2h, as this has become n has become 2, this is 2, this is n. Actually the formula is xn is equals to x0 plus nh. So n value is same 2 as we are in iteration 2, right? Then again all the values or all the formulas I need to use once again. So for iteration 2 I get f of x1 y1 instead of f of x0 y0. Now I am calculating f of x1 y1. So f of x1 y1 will be x1 plus y1. If I put values of x1 and y1, I will get that is equals to 1.21. Next step is to calculate value of k1 in iteration 2. k1 is equals to h into f of x1 y1. F of x1 y1 just now we have calculated, that is 1.21. If I multiply it with h, that is 0.1, I will get 0.121 is the value for k1 in iteration 2. k2 value likely in the same fashion we could calculate. First of all, to calculate the value of k2, we need to calculate these values: f of x plus h, y plus k2, k1 of 2. These values we have to calculate. So to calculate that value, that calculation is done here. See, x1 plus h becomes 0.2, 0.1 is value of x1, h is 0.1, that is why it is. Then y1 plus k1 becomes 1.231 after making the calculation, after putting the values of y1 and k1. Then the next stage is f of x 1 plus h comma y 1 plus k raised to 2. So that could be done by, as we have the equation f of xy is the equation, and for this problem, in this problem statement, that is given equals to x plus y. So instead of x I need to use this value, instead of y I need to use this value, and if I put it, it becomes f of x1 plus h comma y1 plus k1 raised to power 2. So that comes 1.431. Hence next work is to calculate the value of k, which is given by 1 by 2, k1 square into plus k2 square. This square we know is representing the iteration, that is iteration number 2. So in iteration 2 we have calculated k1, k2. I put those values here and I will get k value that is coming 0.13205 is the value for k in iteration 2. Once we calculate k, next work is to calculate y, that is new value of y, that becomes y2 here as we are in iteration 2. So y2 is equals to y1 plus k in iteration 2. K in iteration 2 is just now calculated, y1 is known, that is 1.11. Then if I add the value of k to it, it becomes y2. Hence I will get y2 is equals to 1.24205. So this is the value of y when x is equals to 0.2. That is how we are using this method, that is second order RK method, Runge Kutta method, to solve the first order differential equations. If you understood this problem, if you understood the second order Runge Kutta method, how to use it, I request you to please like this video and please subscribe to this channel so that you will get few more videos related to the numerical methods. Thank you.